Hi, I'm Metta Spencer, and today we're going to Europe and we're going to talk about clouds. And I am very happy to have with me two leading experts on cloud science. In Zurich, Switzerland, at the University of Zurich, is Dr. Ulrike Lohmann, who is, she tells me she had also spent some time here in Canada. So that's good to know. But I've never been uh, to Zurich, so we're going to be talking about clouds anyway. And her former student and now colleague is Blaz Gasparini, who is at the University of Vienna. He is also, of course, a climate scientist. And both of them have been, I think, Ulrike was his mentor or professor at the University of Zurich. So they know each other quite well. We may be joined by another friend here in Toronto. Anyway, I want to talk to you folks about cirrus cloud thinning, among other things. But I invite you to go beyond the boundaries of that topic, which I think is a rather limited topic. In other words, I think of all of the forms of climate repair that are sort of on offer today, this is one that's probably not been studied as much as the others. And so there may be more, I think there is room for controversy about the effectiveness and so on. So you have other things that you've been working on, and I'm very happy if you want to tell us about that. So I'm going to ask Dr. Lohmann to launch this little conversation by giving us a synopsis of what the whole theory or proposal of cirrus cloud thinning amounts to, and then if she has other comments to make about the research that she's doing on clouds that has any bearing or not necessarily any bearing on that, I want to invite that too. So, Ulrike, tell us, as if I didn't know, tell us what cirrus cloud thinning is or what it would like to be.
Okay, we'll do. Just one clarification. I'm at the ETH, that's the Technical University, technical institution in Zurich, not the university, which is quite different. Anyhow, so I'm from ETH Zurich, and yes, I've been researching clouds all along. And we do have very different clouds. We have those low clouds that are dark and gray, where basically no sunlight comes through. And then we have very thin high clouds where lots of the sunlight comes through. So it's still a bright day, but the sky isn't as blue as in the absence of those clouds. And it matters for the radiation budget a lot if you have thick low-level clouds, because as you know from experience, then it's gray below because all of the sunlight is being reflected back to space, or not all of it, but a large portion of it. Whereas for cirrus clouds, most sunlight comes through them and only very little is reflected. So that's one part. So they differ already of how much they basically reflect sunlight. And then the second component is how much of the radiation that's being emitted from the Earth and from the atmosphere is kept back into the system. And then the clouds that are high up, the thin cirrus clouds, are much more effective. They pretty much are the same as a greenhouse. And they work similar to greenhouse gases. They are very high up in the sky. They are rather dense. They absorb all the radiation or lots of the radiation that's emitted from the Earth or the atmosphere underneath them. And then they re-emit radiation to space from their very cool temperature. And the amount of radiation that they emit to space is proportional to the temperature. Now, because they are so cold, very little goes to space, and the majority is kept in the system, so they warm.
Mm-hmm.
And because cirrus clouds warm, and contrails as well, contrails and cirrus clouds warm, the strategies to cool climate would be to, for one, never produce any contrail, so all the aircrafts would have to fly in lower altitudes, so to avoid contrails, or to get rid of all the cirrus clouds that are there naturally. That would be the
idea. Now hold on. That's you've already said something that makes my ears flap. Now you mentioned contrails, and of all the times that I've been holding these conversations, it's the first time anybody has ever said the word. So you're launching a new idea to explore. What's the story with contrails?
Actually, it's only a small fraction of the warming. The contrail warming is really small compared to all the other traffic we have. But it's the visual example. So I was basically using that to giving you an idea what cirrus clouds thinning is aiming at. That was my idea behind it.
So it's not important just because there's not that much of it compared to regular cirrus clouds.
No. Well, two things. In terms of greenhouse gas emissions, much more comes from road transportation and cars and ships, and all that is much more important than the aircraft. But what we don't know about the aircraft emissions is how much of the cirrus clouds that we are seeing are actually old contrails. As long as we have line-shaped contrails, we see them and we can associate them with aircraft. But after a while, we cannot distinguish them anymore from cirrus clouds, and then their contribution could be a bit larger. So yes, it is a small contribution to the warming, to the overall warming that we have from aircraft emissions. That's true. So your friend is right, but it's not the major contribution. Okay. Burning of fossil fuels down there from industry and so is much more important.
Well, now I've heard other people say, other experts say, that a large proportion of the greenhouse gas effect, or the greenhouse effect, is caused by water vapor. Where does the most of the water vapor come from that's doing the mischief?
There is a confusion, actually. At the surface, water vapor is evaporation from the ocean or from plants or from lakes. And if you have too much evaporation of water vapor, what will happen is clouds will form, clouds precipitate, the water vapor goes back to the surface. So you cannot emit too much water vapor, or we don't actually emit water vapor in large quantities near the surface. And and even if we were, clouds form and the water vapor is then converted to cloud droplets or maybe ice crystals and comes back down to the earth as precipitation. But water vapor is a positive feedback. The warmer it gets, the more water vapor the atmosphere can hold. And with that, you increase the water vapor content. So it's not our direct emissions, but if it's warmer, and then there is more evaporation, and then more water can remain in the atmosphere. So it's a feedback to our emissions. It's a feedback to the earth getting warmer that the water vapor content rises.
So you do not put much causal significance on water vapor as the main source of our problem. It's like a symptom. Is that? Am I understanding?
No, it is a problem. It contributes to our warming, but it's not the direct emissions. And you started out by saying that it's the emissions of water vapor. That's not the problem. It's because we emit fossil fuels and greenhouse gases like carbon dioxide and methane and so are rising. They keep radiation back. The Earth's atmosphere system warms up. And because of that, more water vapor can remain in the system. And that water vapor definitely contributes to the warming. But it comes as a positive feedback. And so
yes, that's what I meant by symptom. I mean, it's not the original issue that so much as part of the whole problem, I think I see. Okay, good. Now I interrupted you, your train of thought, when you were explaining this.
So I was basically saying cirrus cloud thinning tries to get rid of the clouds that are there, the cirrus clouds that are there. And that's not a trivial task. It's anyhow not a trivial task to get rid of clouds. But with low-level clouds, we would have an idea of how to do that. We could try to get clouds that are at cold enough temperatures to freeze and form ice crystals. And if that happens, if you have ice crystals and cloud droplets in the cloud next to each other, then the ice crystals can grow and the cloud droplets will evaporate. And that can create holes in clouds. So that works for warmer clouds, not the cirrus clouds, but that works for warmer clouds. And so there's something that's called hole punch clouds. So sometimes you see real holes in the clouds from when aircrafts have ascended, have started. And they basically cause some cooling due to their turbulence over the wings of the aircraft. And that cooling is sufficient to cause ice formation. And then you have ice crystals formed in a cloud that consists of cloud droplet. And the ice crystals grow and leave the cloud and you burn a hole in them. And there have been satellite pictures showing real holes in clouds.
Okay, now here comes Adele. Now my impression again was that the ice in the cirrus clouds, the ice is there just because it's so high that
Yes.
the altitude is the only reason why the clouds differ that much, that the height means that they're going to be
That's true. That's completely true. That's why that method doesn't work, because the cirrus clouds consist only of ice crystals. So if I inject more, if I produce more ice crystals, nothing will happen because we have already ice in the clouds.
Well, I should introduce you, Adele Buckley. Adele is a physicist and engineer. Do you mind a kind of little repetition?
Sure, I can. So when you have low-level clouds, thick clouds, and they appear gray, is because they normally consist of lots of cloud droplets. There's lots of them. There's lots of moisture near the surface, Earth's surface, because it's warmer, and those clouds are thick. They are vertically, they can be vertically thick, but they are for sure optically thick. So they reflect lots of sunlight. And that's because there's ample moisture close to the surface. In high altitudes, you're right, it's very cold. So the clouds will consist of ice crystals for sure. Cirrus clouds form at temperatures -40, -60, or even colder. So there the atmosphere is very thin, it's very cold. There's very little water vapor, so there's only a few crystals and the cloud is thin. So it's thin, there's only little sunlight reflected. Lots of sunlight comes through the cirrus clouds, also called that they are semi-transparent because they let most of the sunlight through them. That sunlight still comes to Earth's surface. And then on the other hand, there is the radiation being emitted from Earth and the atmosphere, and that gets absorbed. It gets absorbed by greenhouse gases, but if there's a cloud in a way, because the cloud is so thick, then the radiation is absorbed by the cloud much more and is then emitted with the temperature of the cloud. So if you have a cloud in low altitudes, it's rather warm. It emits similar amount of radiation as the Earth's surface would. But if you have a cloud that's very cold, it emits much less radiation to space, and most of the radiation is kept in the Earth atmosphere system, and that is warming. So that's, in short, cirrus clouds are like greenhouse gases. They warm the Earth atmosphere system, and the low-level clouds, they are like an umbrella. They reflect. They're basically saving you from the sunlight.
You said something about dark low-level clouds, but some of the clouds, the ones I see, well, I don't see any right now, but most of the clouds that I notice anyway are big, white, puffy things. And wouldn't they, on balance, be reflecting more light away and therefore be more cooling?
The low-level clouds, they're cool. That they appear white to you is just because they are isolated small things. And so some of the sunlight is reflected from the sides and still comes to the surface. But if you are below such a cloud and look up, then it will appear dark at the surface to you.
Maybe you and Adele can help me understand something that Adele and I have been discussing over the last few days or weeks. My impression is that the notion of marine cloud brightening, the mechanism by which it works, is that because it shades the water underneath, if it's over the water, it cools the water, and it cools the locality exactly under the cloud, but that it doesn't really have any global impact to speak of. And therefore, this issue came up when we were talking about the way in which perhaps the optimum way of maintaining or restoring ice in the Arctic. Am I correct in the way I've described our dispute, Adele?
Because the oceans are one big global system, what happens somewhere in the ocean eventually gets to other parts of the ocean, including the Arctic Ocean. And so if we did a huge, extensive amount of marine cloud brightening, then I think cooling anywhere would eventually end up cooling the Arctic and more ice would form. However, one of the things that bothers me about trying to deal with the clouds is that there seems to be no quantitation to this. I mean, as a scientist, I don't like that.
Well, you touched upon many things. So first of all, marine cloud brightening has been simulated in many different climate models. And the way those experiments were designed, the different climate models agreed upon that you can get approximately 1 degree of cooling from it, but not much more. So it's highly unrealistic that with marine cloud brightening, you can do too much cooling. That's highly unlikely. The consequences of marine cloud brightening outside of the areas where the clouds are made brighter, there is some consequences. It's a coupled atmosphere-ocean system. And of course, if you perturb locally ocean currents, it will be transported, it will be felt. But there is a more immediate effect. The monsoonal circulations that we have in Africa and Asia and everywhere depend on that the land heats much more than the ocean does. That's why the air is rising over the continents and precipitates there, and the air that comes up, to replace the air that's rising upward comes from the oceans. Now, if you cool the ocean more, then the temperature contrast between the land and the ocean increases, so the monsoonal circulation is going to increase. So an immediate side effect of marine cloud brightening is that the monsoon circulations become stronger. So it's not only a local effect. So the minute you do it in a large enough, in a substantial way, you have immediate side effects to that. If you do it as small as the Australians do it to save their coral reefs, if you just do it in a very small area, then very likely you don't see any side effects. And then Adele is right about quantification is then extremely hard because we have natural variability in the system. As you know, every year is different than the other. So it's hard. It's like the best comparison is with vaccination. If you get vaccinated or not, you don't know how you would have responded if you didn't get vaccinated or the other way around. It's the same with the climate system. The minute we make those marine clouds brighter, we wouldn't know what would have happened in the same year had we not made them brighter. So the statistical proof is as bad as medical proofs, except that with humans, you have many more to choose from, whereas we have only one atmosphere. So it will be extremely difficult to attribute whatever you see to that particular geoengineering option.
Good point. So it's really like, let's imagine you cool the tropics for 1 degree Celsius, no matter, doesn't matter how. That will actually lead to a bigger cooling in the Arctic. Even though in the Arctic local, you don't do anything, just because that's how the climate works. So maybe it's actually more important that you do something in the tropics or subtropics, even if you want to cool the Arctic.
Go ahead.
Not to work in the Arctic because it's a very harsh environment. It's very expensive to work there. There's the characteristics of the water are probably not nearly as well known as in the more temperate or tropical zones. You have to choose the time carefully. You have to make sure that you're have all the supplies you ever needed in the whole world, because there's nobody to go to and say, I need.
No, it depends on where you are. Like there are small, for instance, Smallbord, there is some infrastructure. But I think what's more important to think about is what Blaž was going to tell you, that how much heat is transported to the Arctic depends on how cold the Arctic is. If you increase the tropics pole, Arctic or Antarctic temperature gradient, you get more heat exported to the Arctic or the Antarctic. So if you cool the tropics, you decrease this temperature contrast, and you basically have less of a heat transport towards the poles. That's the point Blaž is making, just the way the climate system works, not at all thinking about logistics.
Could you elaborate a bit on I am not familiar with whatever happens with monsoons, but that seems like the effect is unfavorable to the people on the land? Yes.
It will be more torrential rainfall, yes. If you do marine cloud brightening, it will strengthen the monsoons. That's what the climate models have shown, and that's what our physical understanding is. Because you increase, like you cool the ocean, the land is being warmed, and wherever the warmest temperatures are, this is where the air is rising and where you get convection and clouds. And if the air rises, it has to be replaced from somewhere else. So then it comes from the ocean and brings all the moisture. So then you have more moisture transport over the land, and you have more rainfall there.
Well, that's a balance in sort of a way. I mean, you have a net bad effect on the land. You may have a net good effect on the water. It's hard to...
Ooh, but the Indian monsoon is, you have already torrential rainfall. I mean, if you have too much heavy rainfall, you have everything. You have mudslides, you have flooding.
Yeah, well, exactly. So who wants that?
Exactly.
Yeah.
Okay, why don't you suggest, or Blaž, either of you suggest, do you think of anything that will be useful as a mechanism of climate repair? What if you let's assume that you've just poured cold water on the whole project of marine cloud brightening, which, by the way, I hadn't heard before. But I'll take your word for it. And then what else have you got?
I mean, maybe one thing to point out. I mean, why did we get to the idea of cirrus and cirrus thinning at first? Well, because that method would work even if there's no sunshine, like in the polar night. So there's still clouds there, and clouds act as greenhouse gases in that situation. And if you remove them, then you get some cooling effect. And also, on the other hand, this is really kind of trying to counteract the greenhouse effect by the CO2 with similar type of climate forcing. So it should be a little bit more equal compared to injecting particles in the stratosphere or brightening the low clouds. So this is a reason why this method of cirrus thinning is attractive. But then why maybe it's less policy relevant, maybe? Well, because what's the maximum you could do with cirrus cloud thinning? Probably not that much, because just those clouds, even if you were to remove all of them, which is of course not possible, if you were to remove all of them from the sky, you would get maybe a cooling of global average 2 degrees Celsius or so. And of course, you'll never get to that extreme case. But compare that with an example of injecting a lot of aerosols in the stratosphere where you could cool maybe the climate for, I don't know, you could bring it to an ice age. That's a relatively small impact. And then if you go in the details, then of
Sorry,
course,
now what you just referred to, you're mentioning SAI, right?
Yeah.
Spraying sulfur into the stratosphere. Mhm.
yes. So just relative to that, it's a rather, even in the most lucky scenario where eventually we would be able to modify all of those cirrus, would probably still not be able to get a huge forcing. We would get something, but not like a huge temperature decrease. But then one is the ideal world and the other one is the real world. And I guess the real world will be a bit more messy than the ideal world.
Mhm. I just had an hour ago an hour-long conversation with Hugh Hunt, and that's sort of one of the things he brought up, is that there is so much resistance. I think he would go for SAI above anything else, and maybe for the same, he didn't give his reasons fully, but probably for the same rationale that you've just explained. But he's not optimistic that it's going to happen because people are so worried about doing anything that would affect the entire world's climate system, as opposed to being able to apply a Band-Aid on a particular local wound of some kind. That's sort of the way he described it. And I guess from my point of view, it has more to do with how quickly you can reverse things. I mean, I have heard people say that there might be excessive rainfall in Asia or even the Sahara as a result of marine cloud brightening, but that the beauty is if something bad happens that you find intolerable, you can just shut off your nozzle and within a week, all of the effects are gone. Whereas with SAI, you've got to wait at least a year, maybe 2 years before whatever you've put up there comes down again and you're back to where you started. So that is, to me, a very important difference. And,
yeah, and there's more differences. I mean, also the type of aerosol that you need for marine cloud brightening is seawater that you have anyhow. So deploying it is much simpler than if you have inject something into the stratosphere, which potentially has side effects like destroying the ozone layer, changing precipitation areas around, and all that kind of stuff.
I just heard a phrase a minute ago, making an ice age occur. What would be involved in doing, how would you do that?
You just wait for a nuclear conflict, and then you get to a lot of dust in the atmosphere, and that's it. There's a lot of studies on that.
Yes, I'm aware of that one, but give me another one.
Yeah.
What else could we do to make an ice age or avoid an ice age, if you like?
SAI.
Now, avoiding an ice age we do by just pollution and emission of greenhouse gases. So avoiding an ice age is probably not the question.
Well, no, but if we went overboard and we did solar radiation management sort of hugely.
That's highly unlikely.
Okay, so whoever is talking about that one, we do not have to necessarily follow that one up and say, well, okay, be careful, don't do this, don't do that. I just
No, I mean, if you were to do something like that, you would start small and see what happens, and you wouldn't go all out.
Mhm.
Good, good.
Thank God. I mean, I think we're talking as if the choice is between a full-fledged, all out effort and nothing. But indeed, just the time it takes to start deploying whatever gadgetry you've put together, it would take a long time to do. And you could start off small and like dipping your toe in the water to make sure it's not going to hurt before you put your whole foot in. I take comfort from the knowledge that nothing is going to happen suddenly, a complete injection of the whole works in one big shot, right?
I mean, actually, who would want to do that? I mean, no single country or private person would want to save the world for everybody else. So, of course, that's not going to work, that this is going overboard.
Okay, but my impression is that, Blaž, the only thing that you answered with was when we said, what else do you have? If you're, it sounds like you're really opposed to even marine cloud brightening, then it sounded like you'd go for SAI. Do you have anything else that you would favor?
I just think that we're the expert on cirrus clouds, and that's where we can give you the best insights. So I'm not sure if we should, explore a lot SAI or ideas to, prevent the Antarctic ice sheet from moving, which is, John Moore's topic, or any more exotic sort of a topic where I'm maybe less of an expert, but if I gave a 5-minute interview, then of course I talk about SAI just because that's the method that we know because of volcanic eruptions. We know that it would cool the planet. For any other method, everything is a little bit more uncertain. So for policy,
look, suppose I give you permission to a disclaimer that we will interpret your next opinions as only uninformed opinions, but nevertheless, as a citizen, you have a right to. And as a world citizen, I think we all have some possibility or obligation, or at least should have a right to express our preferences as to which of these risky activities we are willing to incur. So if you, I personally have some opinions, but I'm not as well informed as you are. And you say you don't know enough about some of these other things to form an opinion, but I hereby authorize you to express yourself anyway.
Well, sure. I mean, you would first say that no matter what you do, it's not it has to be done together with mitigation. And first, we need to do so much more research on that. But then at the end of the day, we know that volcanoes cool the climate, so we know that method would do something. Okay, we know something about ship tracks, so maybe even marine cloud brightening might work with high chances. And we know what volcanoes do to low clouds. We don't know. We don't have any such good analogon for cirrus. That's what makes our understanding of cirrus and of the idea of modifying cirrus rather, less mature and more uncertain.
What about something like ocean iron fertilization, or how about ferric iron oxide, spraying iron salt aerosols?
That's the whole topic of carbon dioxide removal. And I think I would agree with Blaž that we should stick to the solar or the radiation management methods, where you try to change the radiation budget of Earth atmosphere system, because this is our topic. So I think I would say that marine cloud brightening is desirable because it can be deployed in a limited region, like the Australians are trying to do to save their coral reefs. Of course, all of those methods are just a band-aid, right? They don't cure the symptoms, they don't cure the cause, so they don't remove any CO2 from the atmosphere. But if you're curing the symptoms, then with marine cloud brightening, you may be able to do it on a small scale, and it's local and it's quickly reversible. Whereas for whenever you have aerosols in the stratosphere, they stay around for a year or so.
I'm glad you said that, because my whole concern is a sense of urgency about the Arctic ice. and that it's the top priority should be for everybody, saving as much Arctic ice as possible, and if conceivable, even refreezing the Arctic. But that is a local application. What you said about how if you warm the tropics, it would eventually cool the Arctic. I have no doubt that's true, but there's a lot more of the world in the tropics that you'd have to do before that would occur. So I think for short-term urgent situations, the saving of the ice in the Arctic means that using marine cloud brightening in the Arctic Ocean is the most promising thing I can think of now.
But there's much less sunlight reaching the Arctic Ocean, and the marine cloud brightening is, of course, proportional to how much sunlight that is. That's why the subtropical oceans are so much more destined for.
Stephen Salter said that for a short period of time in the summer, the Arctic gets more sunshine than the equator. And the reason is, of course, it's 24 hours a day of sunshine. And yes, I think the difference is that there's a different angle, and the slanty direction of the light probably has some effect, which I haven't heard anybody analyze, how much power that is. But for a short period of time, the Arctic does get a lot of more hours of the day sunshine.
Could I add a comment here? I guess the Arctic in the summer is going to have and already has water that is above freezing, and what happens is you have to, if you wanted to make ice in the summer, I would think, unless you had an absolutely huge effort, you would end up with making ice, which the surrounding water would speedily melt again. And then I don't see how that could possibly be beneficial because summer ice will melt. And then the other thing that worries me is that an effort to do some kind of activity to do the marine cloud brightening is going to require a fair bit of energy. A massive amount of marine cloud brightening, like a huge kind of global type effort around the tropics, say, would require a huge amount of energy. And therefore, again, calculation, rough estimates, anything, please. What is going to happen? You'll actually increase the CO2 levels while you're busy trying to deflect the sun. And
there is the deployment methods that are serious are to try to do it using wind energy. And so the minute you basically inject the sea salt, the sea spray using wind energy, then you don't have more CO2 emissions.
Well, you still have to deploy everything. It would be nice to feel that you were not really warming the atmosphere by the mechanics of the brightening. And yes, I have heard about wind energy, and of course all those things will be super valuable. But it seems to me that you might have a case to make ice, if you have to make ice, in sort of near to the fall, so that it would endure through the winter. Yes, and I'm glad to see that there's a bit of clouds there that'll do something regardless of the sun. So you go to total blackness, and you stand by and wait, and then you have made more ice, which will do good work for you in reflecting sun in the spring.
Well, but the problem is the minute polar night comes, the clouds in the Arctic only warm. Then there is no reflection of sunlight anymore.
Yes, that's true. But eventually, spring will come again, and then the extra ice that's been waiting all winter will reflect more sunlight.
But you can't do marine cloud brightening in the fall if you don't have any sunlight. Then you cannot reflect more sunlight. So
Oh,
the
no,
middle
you don't
polar
do it in
winter
the,
comes.
no, you don't do it in the dark, but you do it, I don't know, August or something. Anyway, it's pretty hypothetical, but anyway, I do worry that if you went to all the effort to make ice in the Arctic or the Antarctic, it would simply melt.
Yes, very likely so. Very likely so. We did some climate model experiments where we didn't change the cirrus clouds, but lower level clouds over the Arctic, because over the Arctic in winter, actually all clouds warm. So it doesn't really matter which clouds you remove. And yes, we were able to keep the sea ice for a bit longer, but only it will still melt in summer. So if you get some cooling, it's hard to survive in the summer, the sea ice.
Well, that just goes, to my sort of argument that I don't like to do this work in the Arctic. I would rather see it done in a more favorable place on a larger scale, etc.
But you said before that it's not good to do it in the tropics because the tropics cover such a huge area.
Well, yes, I mean, I'm sort of assuming that somehow a project is mounted using wind energy and all sorts of useful technology that is gradually developed over the next, I don't know, 10 years or something. And now we have a major project in the tropics, which eventually ends up helping the Arctic or Antarctic. But this is kind of a dream because we have to get there from here. I also like to mention one other thing because all I do is look at maps, if you like, of ice from time to time, and I always see that the area north of the Baltic states and around Svalbard and toward Murmansk always looks to be empty of ice. So I don't know if that's a good place to do this work. What do you think?
I'm not an oceanographer, so I wouldn't really know how you would, which region you would target. But I think if we're talking about marine cloud brightening, we're talking about the subtropics, because those are the areas where the clouds cool the climate system most in the current climate. So that's the subtropics that we are talking about. And then you are right, there's the thermohaline circulation that transports the water back to the poles and also into the Arctic Ocean. So if you cool the subtropics, what is going to happen, then there needs to be much less heat being exported to the Arctic. And that would probably slow down the circulation a bit more.
Okay, well, how would we encourage such an activity to get started or to be planned, or how do you do that?
The Australians are doing it for us. They are doing it to save their coral reefs, so they are starting it locally, and we can learn from them.
Well, yes, I was hoping that there would be learning from them. I have another question, which is anyone that you know of in Canada working on these topics?
In Canada, I don't know who's working on on geoengineering in Canada. Do you know, Lars?
There was some work, I think, in Victoria, but I'm not sure if that person is still there. Someone actually who worked or a little bit collaborated also with Phil Rush, I believe. Can't remember, but that was Victoria.
Denman, there's a Kenneth Denman at University of Victoria. I can't remember. Is that who you're thinking of, Blaž?
No, probably not. I mean, yeah, I can't remember. I mean, it was maybe Hansi Singh, who maybe, I'm not even sure if she's still there. Maybe it was her group. But anyway, yeah, not that much in Canada itself. But over the border in Seattle, yes. I mean, they we're now in the headlines of New York Times and so on with their experiment in San Francisco Bay Area, where they have an initial test of a sort of marine cloud brightening. I mean, it's not really doing anything to the clouds, but just the injection of salt water. So that is now what was just, very prominently featured in the media maybe a couple of weeks ago.
I've seen something about that. Well, why we talk about Canada involvement is that there's a group of Canadians who would like to see something done within Canadian jurisdiction, because that would make it much simpler. If just one country has to say yes, go ahead. We see no support from Canadian scientists for that. I mean, not that they're not supportive, they just don't work on that area at all. So I wonder, what do we know about governance? What permission is needed to do some of this work?
So anyway, now I have the name. It's Haruki Hirasawa. I think he's a postdoc, UVic. I'm not sure if he's still there. And I think he was in the group of Hansi Singh.
Would you email that to me, please? I'll follow it up.
And
Appreciate that.
they did work on marine cloud brightening in particular, so that might be interesting for you.
If I were to characterize you, both of you, your attitudes are, well, bracing, let's put it that way, very putting us into clear awareness that the risks are really there. I don't doubt that they're there, but I don't talk about them that much, and I don't hear my friends talking about them as much, because I tend to hang out with people who are really promoting some of these other innovations. But I would say that you would probably be counted as an opponent of geoengineering. Wouldn't you? I mean, don't people in the press characterize you as a critic more than a supporter?
Well, it depends. The last scientific papers that we wrote on cirrus cloud thinning came to the conclusion that the method doesn't work. So in that sense, I stand to that I don't think that cirrus cloud thinning, as attractive it may be from the theory, the harder it is to do practically.
But you do seem to sort of support marine cloud brightening with a lot of caveats.
Yes, marine cloud brightening with some caveats, yes. And also what has come out of our group is rather that we are trying to get rid of some clouds that are, in terms of the level in between the low clouds and the high clouds. That's what I was starting to tell you earlier on. If they consist of cloud droplets, but at temperatures below 0, and if you, in those clouds, inject some particles that cause ice formation to go on, then you basically can create holes in those clouds. And that could help the Arctic. That's what we at least have shown with climate model simulations.
Okay, now
how much
I think
material do you need? Like, you could take desert dust, so that would be some material that's readily available, that would work. We don't know at the moment how feasible that is, what kind of quantities that you need, but there could be something that could locally help the Arctic. Maybe.
Now, about a year or two ago, I had a guy named Michael Diamond on the forum, and he mentioned and later he sent me a copy of the paper on, I think, mixed phase.
Yeah, exactly.
Thinning. And so I thought I should follow up on that, but that's the only paper I've seen on it. And I'm surprised and delighted that you mentioned it again, because if you put down cirrus cloud thinning as impractical, but you think that there might be something for this mixed phase cloud thinning, then tell me how I should go about exploring that further. Has there been more work done on that? Are you working on it yourself? And
yes.
Can we get more information about that? Because that, I'll take anything that looks promising. If you have something to sell, I'll buy it.
No, we have so the first author on that paper is actually in my research group, and he got more funds to look into that in more depth. So at the moment,
Somebody
nothing
named,
more.
surname starts with a V. Is that
Yeah, Villanueva, Diego Villanueva.
okay? And he's in your research group. Well, good, good, good. Okay. So maybe I should go talk to him, you think?
Yes, yes, I can
Okay.
recommend that.
Okay. And are you yourself engaged in looking at that stuff?
Not so much, no.
Well, how much potential would you say? I mean, Blage said that even if you did the best, you'd only get 2 degrees cooling or something on the most optimum circumstances, et cetera. If
1
you,
degree.
I mean, how many of these mixed phase clouds are there? How likely is that you could do much with it? Tell me more about what that is and what that might offer.
It's only regional. It's only a regional thing that you could do over the Arctic, because you want to have those mixed phase clouds that Diego is studying only act like greenhouse gases in the Arctic winter or the Antarctic winter.
Mhm.
Only then is the warming effect larger than the cooling effect. So because during Arctic summer, they reflect more sunlight,
Mhm.
so you don't want to get rid of them. That would have the opposite effect. So
Mhm.
only in winter time, polar winter, do they actually warm. And so you can only get rid of them during polar winter to have an effect.
Well, I'd heard the same
Regionally
statement.
limited to the polar winters.
I'd heard the same statement about cirrus cloud thinning, that you wouldn't do it anytime except the winter, right?
Yeah, the same idea.
Yeah, okay, that's logical. Okay, so I thank you for that, because that means I have something new to explore, because you just shut down some of my favorite things, or at least poked holes in them. And I think I want to, I'm on the lookout for anything that will save the world. So all the help that you can give me, I think we all can use, right? Okay. So Blaž, do you have anything you want to add to this? Because we've, yeah.
Maybe I'll just add, like, while we both with Ulrike think that cirrus cloud thinning might not really lead to much of a cooling, I think it's still just the uncertainty in formation of those clouds are huge, and what we've done so far is not enough to really constrain, particularly from the scientific perspective. I mean, also from the geoengineering perspective, and that's why it's still worth to do some studies on that, particularly with some models which have high resolution, which can resolve the smaller scale motion. Many people have done a lot of these studies, like Michael Diamond for low clouds, or, well, maybe not him that much, but some other people for low clouds, not that much for high clouds. So I would still go on for some studies related to that and related to cirrus thinning, while being aware that probably we don't get much bang for the buck with that specific geoengineering idea.
Mm-hmm. Well, my sense is, I keep thinking that doing something in the Arctic is the only solution, because it's so urgent, because we're in what I consider really crucial. We don't have any time left. And I think that's also what other people have been saying to me. Hugh Hunt just a couple of hours ago, agreeing that we need action pretty quickly. So I think that because only, we could do it in Canada, maybe not Hudson Bay, that's a little water, maybe too warm there, but farther north, maybe. And at least keep it cooler in the summer, so that when it freezes over in the winter, you have a better chance that it'll stay cold longer the next spring. And I think that's the most you can hope for, is try to show that you can prolong the ice in the Arctic as much as possible. So we've gone over time, and if anybody has anything you'd like to add, feel free, but otherwise we'll have to say goodbye.
Just really quickly, give me an estimate of how soon if we decided, as the globe, I guess, could we do a full-scale activity which would actually have an effect, which would not just be an experiment, but which would affect the cooling? How soon? A number of years, decades, whatever.
You have to talk to the SAI community for that, because in order to see a global effect, it's SAI. And they have better estimates because some groups have been trying to start to do some small scale deployment to figure it out, and there's lots of obstacles that they need to get over. So
I think there are certainly people who could do things right away. I think probably the quickest thing that could be done would be iron salt aerosol. That they could, within a year, I think they could spray ferric oxide in the troposphere.
It doesn't make sense to want to get to a cooling too soon, because exactly as Blaž said, we need to start somewhere small to see if the side effects are as we envisioned them, or are they maybe more benign, or if they're more severe. So we need to be rather careful with that.
Anyway, I guess we have, I really have enjoyed this, and I've learned a lot. And I hope that we have further conversations about this at some point when I've learned enough to come back with you with new questions, because you're the people who really know certain. I especially am keen to explore this thing about the mixed phase cloud thinning.
I'm sure Diego will be happy to talk to you about it.
I'll get to him. Thank you so much. Say
You're
goodbye. Project Save the World produces these forums. This is episode 602. Watch them or listen to them as audio podcasts on our website, tosavetheworld.ca. People share information there about 6 global issues, and we welcome your comments too. To find a particular talk show, check the scroll list on the home page or use the search bar. Project Save the World also produces a quarterly online publication, Peace Magazine, which now serves as a free-of-charge newsletter to help mobilize knowledge about 6 global threats to humankind. We gladly email the magazine as a PDF or link to any interested organization in the world that works to prevent a global catastrophe involving war and weapons, global warming, famine, pandemics, radioactive contamination, or cyber risks. Just email us at office@peacemagazine.org, and we'll add your group's email address without charge to our list. Please type "Subscribe my group" as the subject of your email. For individual subscriptions at $20 Canadian per year, go to pressreader.com on your browser and search for Peace Magazine.